Hello grade 9 students, let's proceed now to our next topic. This is part 2 of our lesson in variations. So last time we discussed about the different types of variation, the direct, inverse, joint, and combined variation. So the melt for this topic translates into variation statement the relationship between two quantities given by table values, mathematical equation, and graph, and vice versa. Learning objectives: translate variation statement to an equation of variation. Number 2, identify an equation of variation as direct, inverse, joint, or combined variation. Find the constant of variation given a table of values and graph. And number 4, translate table of values and graph to an equation of variation. So let's have a review. Direct variation: if the ratio between two quantities is constant, it means that one quantity varies directly as the other quantity, or the two quantities are in direct variation. For two quantities x and y, an increase in x causes an increase in y as well. Similarly, a decrease in x causes a decrease in y. Yan ang direct variation. So the statements: y varies directly as x, y is directly proportional to x, and y is proportional to x. Alright, maybe translated mathematically as an equation of variation: y equals kx, or k is the constant of variation. Example: m varies directly as n. This can be translated to an equation: m equals kn. Solving for k, we have m over n. Divide both sides by n. So k equals m over n. How about b? X directly proportional to the square of y. Translated to an equation as x equals ky squared. So this is an example of direct square variation. And so for y, we just divide x by y squared. Another: a is directly proportional to b. So pag equation a is equal to kb. Solving for the constants, we have a over b. So the table here shows the relationship between the distance by a runner and the period spent. So if the time is 1 hour, okay, the runner will get to the distance of 20 kilometers. 2 hours 40 kilometers, 3 hours 60 kilometers, 4 hours 80 kilometers. So the table shows direct variations that can be translated to an equation: d is equal to kt. Solving for k, we have t over d. The number of hours increases as the distance also increases constantly. So this is an example of a direct variation. As x increases, as r increases, kilometers also increases. And if we're going to graph it, we have here it's a straight line. It's actually a straight line, and the k, which is equal to 20. Yes, we divide by 1 is 20. That means that is also equivalent to the slope. Alright. So we have here the graph. The graph shows direct variation that can be translated to an equation: d is equal to kt, or solving for k, we have t over d. Now, to solve for the constant of variation k, an equation of the variation using the table of values and a graph in the direct variation. Okay, number 1, use a coordinate and substitute it in the translated equation. Use coordinates 130. Where d is equal to 30, t is equal to 1. So, solving for k, we have d over t. That means k is equal to 30. Substitute k equals 30 and d equals kt. That means d is equal to 30t. Right? So that's an example of a direct variation. So wait, if we're trying to use this, okay. Alright, so what we did here, we have 130 is, we base it from the given graph, not from the given table, okay? So from the given graph, we have 1 hour 30 miles, 2 hours 60 miles, 3 hours 90 miles, 4 hours 120 miles. Not with the table, alright? Maybe we can change the table, no? Pero so okay, maybe the table is different from the graph, so that to solve the equation of the graph, not the table, so we use coordinates 130. So the equation is, let's first solve for k, which is 30. Substitute that to d equals kt equals, we have d is equal to 30t. So let's proceed to the inverse variation. So pag inverse variation, it occurs whenever the situation produces pairs of numbers whose product is constant. So for two quantities x and y, an increase in x causes a decrease in y or vice versa. So pag inverse, as x increases, y also decreases. And the statement y bar is inverse this x is translated to an equation y equals kx, k over x. Pag direct, y equals kx. Pag inverse, y is equal to k over x, where k is the constant of variation. Examples: O bar is inverse this p, so that can be translated as O equals kp, k over p. To solve for k, let's just multiply O and p. M bar is inverse this is the square of n, so it's translated as m is equal to k over n squared. R bar is inversely as the square root of s. It's translated as r equals k over square root of s. Now let's have here a table. It shows the relation between the length and the width of the rectangle. Yan. If the width is 2 and the length is 12, the area is 24. The width is 3, length is 8, 24, area. 4 and 6 for the length and width, 24, and area. If the width is 5, length is 4.8, still the area is 24. So the table shows an inverse variation that can be translated to an equation W is equal to K over L. Right? Because as the width increases, the length also decreases. If the width increases, length decreases. So there is an inverse variation in this work. And from here, you can tell that the area is the same, 24. And the equation is W is equal to K over L. And if you're going to solve for K, just multiply W by L. So it's equal to 24. K is equal to 24. Now let's have another graph here. This is a graph different from the given table. So it involves depth in feet and temperature in Fahrenheit. So we have some of the values. If the depth is 2000 feet, the temperature is 7. So as you can see here, as x decreases, y increases. So this graph shows inverse variation that can be translated to an equation. T, temperature is bar is inversely as the depth. So T is equal to K over D. Yan ang equation of the variation. So if you want to solve for K, just multiply T and D. So to solve for the constant of variation and the equation of the variation using table of values in the graph and inverse function. Okay, let's choose the coordinates 528. Here. 528. Then from the equation of the variation is equal to T equals K over D. To solve for the constant of variation, we just multiply T and D. 500 times 28. Yun. Which is equal to 14,000. So 14,000 is the constant of variation. If you substitute that in here in this equation of variation, T equals K over D, then we have T is equal to 14,000 over D. Okay. So that's an example of an inverse variation. Let's proceed now to joint variation. The statement A varies jointly as B and C is translated in an equation A is equal to KBC, where K is the constant of the variation. So joint variation takes place when one quantity varies directly as the product of two or more quantities. So examples: M varies jointly as N and O. So when it's translated to an equation, M equals K and O. R varies jointly as S and the square of T. Translated to R is equal to K as T squared. K is the constant of variation. A varies jointly as the square root of B and C. Translated to A equals K times the square root of BC. Okay, that was joint variation. Let's proceed now. Combined variation. So combined variation, say varies directly as X, inversely as Y. So it's a combination of direct and inverse variation, or combination of direct, inverse, and joint variation. So how do you translate Z varies directly as X inversely as Y into equation? We have here Z equals Kx over Y. So since varies directly siya, Kx, inversely siya over Y. K is the constant of variation. So combined variation takes place if one quantity varies directly or jointly as the other quantities, and inversely as the other quantities. It involves combination of direct, inverse, and joint variation. Example, M varies directly as N and inversely as O. Translated to an equation, M is equal to Kn over O. X varies directly as the square of X, square of Y, and inversely as Z. Translated to an equation, X equals to Ky squared over Z. A varies directly as B and inversely as the square root of C. Translated to an equation, A is equal to KB over square root of C. Let's proceed now to exercises. A. Identify the given equation of variation as direct, inverse, joint, or combined. Number 1. A equals K over B. Answer, inverse. A varies inversely as B. How about here? Number 2. A equals KB. It's a direct variation. A varies directly as B. How about number 3, inverse again? A varies inversely as B. How about number 4, joint? A varies jointly as B and C. And number 5, that's A, combined variation. A varies directly as B and inversely as C. I think you can be able to differentiate now direct, inverse, joint, and combined. Now, write an equation of the variation for the following statements. The cost C of price varies directly as its weight. What's yours? What is your equation? C is equal to KW. Kasi direct siya, so C equals KW. How about this? Again, number 2, the circumference of the circle varies directly as the length of its diameter. Direct variation again. C is equal to KD. Number 3, the weight of water varies directly as its volume. Okay, puro directly, no? Puro directly ito. So, W is equal to KV. Sa perimeter, direct na naman. P is equal to KS. And number 5, areas of square varies directly as its side. A equals KS. So, puro ba, ano yan? Direct variation. Write an equation of the variation where Y varies directly as X. First, pag direct variation, so we must solve for K, constant of variation. So the equation of variation is Y equals KX. So if you solve for K, just divide Y by 2. So that's equal to 1/2, diba? Then substitute K to Y equals KX. So for number 1, Y equals 1/2 X. Because K is 1/2. So naman, just divide 20 by 4, 5. 5 is a constant of variation. Therefore, equation is Y equals 5X. Ito, 0.8 divided by 0.4. 0.2X. 40 divided by 8, 5X. And number 10. And number 5, 10 divided by 15, 2/3 X. Y equals 2/3 X. Write an equation of the variation where Y varies inversely as X. Okay, pag inverse variation naman, to solve for K, just kasi ang equation niya is Y equals K over X. So, to solve for K, just multiply X and Y, or Y and X. So, for number 1, what is the value of K? 16. 8 times 2, 16. So, the equation is Y equals 16 over X. Ito, number 2. Y equals 32 over X. Multiplied 4 and 8. Number 3, Y is equal to 450 over X. 15 times 30, 450. 9 times 12, 108 over X equals Y. 42 times 14, 588 over X equals Y. So, examples of inverse variation. Write an equation of variation where A varies jointly as B and C. Okay, joint lead involves two or more variables, A and B and C. So for number 1, A equals, yes, how do we solve for the constant of variation? You just divide 12 by the product of B and C, which is 12 divided by 6, which is 2. So A equals 2BC. Ito naman, A equals number 2, 1/2 BC. A divided by 16. So 1/2 BC. 50 divided by 10. Product of 5 and 2 is 10. So 50 divided by 10 is 5. Equals 5 BC. 4 divided by 16, 1/4. A equals 1/4 BC. 48 divided by 6, 1 equals 8 BC. Gets nyo? Very good. Write an equation of the variation where z varies directly as x and inversely as y. Number 1, z equals 8 when x equals 2 and y equals 3. So how do we solve for the equation? Is z equals kx over y. Kx over y yan. So kx over y. So to solve for k, you just multiply z by y divided by 2. Yan. Multiply z by y divided by 2. Or z times y divided by x. And then substitute in the equation y equals kx over y. So 8 times 3, 24 divided by 2, 12. Okay, z equals 12x over y. Yun. 12x over y. Baliktad yata. Z varies directly as x. So, teka, baliktad. Kasi varies directly as x eh. Inversely as y. Baliktad. For number 2, okay, pwede yan. Pwede yung answer if we're going to change the direction. Say varies directly as dapat itong mag-change eh. Right, baliktad, okay? 12x over y kasi varies directly as x. 12x over y. Tama yung constant of variation niya. So palitan lang natin. 12x over y. Also here, 10x over y. Inversely as y kasi eh. 10x over y. Okay. 4x over y. 10x over y. Yan. Let's continue. So for number 1, the answer is z equals 12x over y. The solve for k, which is 12, 8 times 3 divided by 2 lang. For number 2, 10 times 3, 30 divided by 3. So 10x over y. Ito naman, 5 times 12 divided by 4, which is 15x. Which equals 15x over y. 8 times 3, 24 divided by 6. Z equals 4x over y. 12 times 5 divided by 6. 10. Z equals 10x over y. So that's better. Right? Okay, so I think we're now through with our part of our topic variation. I hope you learned a lot. Thank you very much and see you next time. I will discuss again another version of variation, version 2. Bye.